3, 2, 1. We are here.
Yay.
So, welcome to performance tuning optimization from zero to hero session. My name is Alex Grimberg, my co-speaker, Saeed Salomon.
Hello.
Few words about myself. I am in the industry, I would say, over 30 years. It's very hard to count a precise number, but I grew up with computer in my hands. So after being front-end developer, I became to database professional, starting developer, then administration. So at my front-end skills allows me to go deeper in the SQL Server world. Few words.
Yeah, my name is Saeed Solomon. I have comparable experience in SQL Server and IT in general. I grew up on what's called a computer service bureau. So I have had access to various front ends, from everything from insurance, which is what I work in now, to manufacturing, to just accounting, whatever application you're talking about. I probably have touched it at least once or twice. And I started to go into database administration because it seemed like a good fit for me. And I've also turned around, and I'm using, my company is currently using AWS. So I got AWS certified. So I'm a certified solutions architect associate level. And that's pretty much about me. I work for Kemper Insurance as a database engineer.
So that's what I promised to you. That's my book I wrote some time ago, covering JSON, XML and JSON for SQL Server in a recipe format. Very easy to follow, very easy to read. It's kind of from DBA to DBAs. Not only DBAs, or UI as well. So welcome to, if you need get deeper knowledge for XML and JSON, that technology grows. If you're aware, Microsoft released for Azure JSON data type, and that's going to be available on the next on-prem version. I was volunteer for Microsoft to test this JSON data type, kind of privilege, take it and see it in a first step. So our agenda today. We will touch indexing strategy, not too deep, because indexing, it could be absolutely different session if we take from ground zero to a maximum level. It's I would say it's easily fits 1 hour. So indexing strategy, it's one of the part of performance tuning optimization, and plus one issue what I would like to cover the most. It's a part of this session. This session cover many aspects of performance tuning and optimizations. It's very tight with indexing strategy and how indexes utilized, and what mistake could taken by developers, and not only by developers, sometimes, and I'll demonstrate to you when incorrect request from user interface killing index. So data type mismatch conversion, that's one of the very important, and it's kind of hidden danger. Execution plan XML. I already mentioned before when audience gathering, everyone, most of us, we look as a performance tuner. First thing what we're looking for, show me execution plan. We take execution plan, we're going from task to task, find out, analyze, but rarely we open execution plan in XML format. I'll demonstrate to you where it could be very useful without asking additional questions, user interface team, .NET team I'm working with, or could be Java team who sent us data. Extended event report. I'm not going to cover extended event, how to build up. It's not a big deal. You can open a wizard and go and create extended event. Majority of questions what I have as a book author, it's how to parse, because output of extended event is XML, and you can find sample for extended event, lots of examples how to build up, but when you need specific element to show up, that's the it could be 1,000 different options, so you can't find parser that 100% cover your needs. So I'll show you very easy way, and trust me, after this session, you never ask this question. It's I hope it's going to be write report for over the extended event, no longer an issue for you. Deadlock report. That's a feature available, I believe 2016 or 2017, I don't recall.
The latter part of 2016.
Yeah, 2016 for sure. We have built-in extended event that collect deadlock data. So we will go over how to obtain that and how to read it. Statistics. That's Said will pick up and go over the statistics. Server optimizations, query store, then bonus. If we have time, if we have enough time, I have a number of live issues, practically from my personal experience. Most mistake that developers, not only DBAs, we have, as a DBAs, we have issue with .NET guys send us request, they write something. Another team, let's take my position in a company, it's a many teams, and they unfortunately kind of isolated. Everyone write store procedures, they write dynamic SQL, and no matter what, if something wrong, IT rule number one, find who is guilty. So who is guilty? It's a database performance. Go and fix it. That's your problem. So if we have enough time, I will go over and show cases how it should be better to write and correct some code. And at the end, we're more than happy answer all your questions. Only my suggestions. If you have the questions during presentation, I would recommend you write it down or remember, because if you start questions during a session, it's never done. I know what the end could be. I'm not gonna cover, we say it, we're not gonna cover what we plan to do. It's not because we cannot answer, because just optimization of our session, because we are on a performance optimization. Let's be optimized for everything. So let me go to SQL Server and let me start from one story. And this story I believe this story begins about 10 years ago or so. In each client that I worked with after that, each client have the same issue. And I called this issue, that's even a very political, conflicting issue. I call it works on my machine. Oh, you're laughing, you know what I'm talking about, because what I said before. Rule number one of IT, find who is guilty. But always another team. So, right. So, let's say I am UI developer, C# developer, and I have task. I need to write code to populate drop-down list. And this drop-down list, when user select, then it populates or write report or send something. So that's the query example. Very simple query. Again, it's not a life. I just build up close to situation that I have. Very simple query. Let me turn on famous execution plan. Developer wrote the query, and developer wrote the query. Then in the first run, he found, okay, index is missing. He created index. So index is there. And when developer ran the report, execution plan, and you see index sick. You see well, right? Index sick. What could be better? 100% bingo, right? What you want from me? That's already there. So, about indexing, I just step out for a sec, and a few words. I don't need to connect because I'm not gonna write anything. About indexing. Does it familiar for you? Let me make bigger. DTA underscore DTA something. So I always recommend when I start contract or hiring by company, I always recommend to enforce naming convention standard, because you can see that's two indexes. Names, they have a different name. But practically speaking, you see key value, product key here, plus include, which is subset, product key here, another include. Practically, it's a duplicated index. The difference is subset include clause, which is, it's a subset, it's not a key value. So, few things that I would recommend DBAs and my manager, when I hire or have a contract, enforce naming convention. If, for example, it should be prefix, let's say IX, then table name, then key column, not include. If someone naming those indexes table key column, it would raise error index exist. Number one, before even when I run report, index recommend missing index report. And in the report, I have bunch of indexes, even 90% improvement, 80% improvement. I never blindly create an index. Always review a table, take extra hours. Sometimes it's a time consuming, but it should be understandable. If you create more duplicated indexes, performance not gonna be better, it's just be worse. Plus maintenance, plus storages, and such a thing. So enforce naming convention, review your indexes. And the big part of the indexes I cover, that's part of beginning session, and additional information I'll cover later. Column that wrapped in a where clause with any function kill indexes. So that's the very important things. Now, let's go back to query that we have. Oh, no, it's not this one. So I have a query, and that's my user interface. I started program. I still UI developer, not DBA yet. And I run my report. And what happened? And that was live situation. As usually, Friday, 3 p.m., when you think about a glass of beer in a restaurant, deployment, and deployment raise bunch of blocking. Server like a crazy. Everyone running, what's going on? What's going on? What happened? What happened? And I'm running my analytics, and I see execution plan, and I see index scan. Why? I just showed you a few minutes before. It was index sick. I just ran it's an index scan. Okay, I grab this query, I send to developer. Your query not optimized. You send to the system index scan, and I work the company that have it's a covering about 80% of nationwide automotive industry, and have about 200,000 requests per second. This query in a mid-level activity, a low-level activity, maybe doesn't matter, but in this specific situation, it's just to blow the server. So send a request to UI. Guys, what's wrong? Your query failing, not failing by data, your query blocking, create a bunch of blocking. Excuse me, it's work on my machine. He sent me screenshot with not scan. He sent me screenshot with sick. Okay, I sent screenshot with scan. Okay, who is right? So we continue working on that. What's going on? And what we have, that's the query, that's the text output. In right here, to reproduce, I'm open up in XML, and what I see warning, and I see convert implicit. Maybe you already familiar with that, but you're familiar with that it exists, but do you know why it's happened? Why he ran and actually we're expecting normal index seek, not index scan. So that's one place when I look at the execution plan, I see, okay, that's converting n varchar to this column. And okay, column is a varchar, but system converting column to n varchar. Why it's happened? So the best way to find out what's going on, we need to find, at least that's my strategy. I need to get actual value, what sent this request, not only query, because execution plan, when you click right here on the multiple dots, that send you parameter name right here with data type and query, if query not too big. But what you need the actual parameter value. To get parameter value, my recommendation, Control F and type parameter list right here. So right here, I can see my column. That's the parameter name. That's the data type, and that's the actual value. It's brilliant because number of times when I try to pick up my own value, this query could work, parameter sniffing thing or other thing. It's very important to have exactly the same value that have issue with specific SQL. Parameters, this query have one parameters, but how many parameters do you have that's going to be listed on this report inside the execution plan? That's why when I open execution plan, I go and switch to XML to see what's inside. And actual parameter, it's one of the key for proper performance tuning. So we have a parameter. I grab this parameter, JSK. And so he expected as a varchar, and when UI developer run with execution plan, this plan have seek with varchar. But system show it as a n varchar, and that's where it's coming from. So now I need to back to my PowerPoint, and one thing what important you need to know, and you need to provide training for your UI guys. We have data type precedence. What means data type precedence? One data type prevail on another data type. And if you take a look, number 25, 26, 27, 28, it's a 25, 6, 27, 28, right. It's a textual data types that going on a specific sequence. Convert implicit happen when referencing value, referencing data type by sequence, higher precedent value. If they send varchar, they specify from UI varchar, that shouldn't happen. But system, UI developer did not specifically send Unicode, and varchar it's a Unicode. He just wrote the code, it's happened this way. And I'll show you this code, and this code, it's a crucial answer for any conflict. So saying it's work on my machine, that's not gonna work. And that's how you could prove, because just sending, he's sending me his query with a screenshot, it's an index seek. I send back with index scan, and it's an infinity loop. We just can sending, but what the root cause? What the root cost of that? Now, you don't need to know .NET. It's not our responsibility. But if you can cover this question, that's you will be hero. Just a second, let me find the code and I'll show you the difference. Okay, so that's the killer. This function have only two parameters. Give me parameter and parameter value. .NET and another UI, maybe Java or something else, doesn't have granularity of textual data type. On a SQL, we have varchar and char. We have varchar and char. For .NET, everything is string. It's a string data type. So could be variant, but it's not a specifics what we're expecting. It's a string, it's a textual. Textual is a string. So when they say, okay, I have this parameter, I have drop-down list, and I have this text. Okay, this text it's a string. String, it's in a .NET word, it's by default, it's a Unicode. Unicode is n varchar, correct? So, C# engine grab this parameter and send the parameter as a n varchar, as a textual Unicode. Because code doesn't have specification what data type to use. And in the presentation for when this issue was found, and I provided presentation for entire team, entire .NET team. That's the request was, you have function add with value. Instead, you need to use add collection. Add collection, if you see syntax code, add with value much simpler to use. It's a function, it's a provides, give me what parameter name and value what you attach to this query on a dynamic query, because from drop-down list, it could be multiple selections. One selection, but you have multiple values. Versus add is a collection, because inside you need to instantiate, make an instance for SQL parameter. That's the parameter name. And then next, it's a SQL DB type. And then when SQL DB type, it's a referencing. I send this value, not a regular string. Use this value as a specify ANSI standard character string, not Unicode. So this way, when developers use, instead of add with value, use add collection, that provides proper call. And now let me go back to a user interface. And when I start, click button normal, now you can see it's an index sick. That's how it should be. And that's the issue. That's the issue. Let me stop because it's trying. It's pulsing every couple requests per second. So that's how to solve this value without internal conflict. Just saying, okay, you are wrong, it doesn't tell anything. You need to point, okay, maybe it's a query. Okay, query, it's a database deviated. You guys check your server not properly set up, your database doesn't have what should be, not enough memory, not enough CPU, whatever it is, but no one say, excuse me, it's my code I wrote, I pick up wrong function because it's fewer characters, less than I should call. So that's only way how you could actually say and point out everything to solve any conflict, at least in my situation. If I have in the code, someone send me code and I see code is kind of conflict with what could be, I write parallel code. And I'm running two versions and say, okay, this version, for example, executes for 1 second. Another version executes for 500 milliseconds, like a half time. What you're going to pick up? No conflict. That's the obvious example. Always solve the conflict. Now, next question probably you have. How to catch it? Because I can't say 100%, but I wouldn't be wrong if I say 90%. If you run query that I'm going to attach to this presentation, you will find some of examples on convert implicit that we can't directly blame someone. Maybe UI developer, they're not aware of that. So it's a new function, less parameters, works well. Why it's an issue? What's wrong with that? But when you explain, and just let's say couple months ago, when I catch another problematic query, and I just wrote to UI, would you please check your code? Highly likely you're using add with value instead of add collection. And he wrote back, yes, you are correct. I didn't even look for what he wrote, but it's execution plan and all statistics say that. I telling you, 90%. When you run query, you will see number. Another thing is how important. Sometimes when I see convert implicit, but if it runs once a day, and instead of running half milliseconds, it's running 1 second, I wouldn't raise any issue. But when I see some code, for example, recently, query runs like at 20 minutes. The same issue. When I just corrected, I pick up the SQL, I pick up what the actual values from parameter list in the XML in the execution plan, and reran corrected instead of declaring n varchar, I declare varchar. That query returns in a couple seconds. So in this case, yes, I sent, it's a big issue and needs to be work on that, and it's not a database issue. You need to check your code because highly likely you're using incorrect function. You're just sending a string instead of sending internal ANSI format variable to SQL Server request. So kind of take off your plate. Now, next thing, how to catch. How to catch this process. Let me see. Okay, I need to. So that's, I have two variants how to catch convert implicit. One using exec query stat, DMV, and then text, then query plan. Another one, it's a request, and then a text and query plan. So that's why I would recommend you to be more familiar with XML parsing, because execution plan is XML, and you know it could be potential problem for you. So to parse execution plan, you need to be familiar with XPath language, which is explains on a book what I pointed you before. Let me quickly go over the parsing. First of all, in the execution plan, XML, we have a XML namespace. Without declaration, it's not gonna work. If I comment out and try to run, I receive an error because some elements pointing to namespaces. If namespaces is missing, it's to one worse thing, another kind of, so you could get empty result set. Even your XPath parsing is correct, but without declaring XML namespace, it's not gonna work. That's how XML internally works. Or you could get error for example, where here PLN is missing. So in this parsing example, to get taking out expression and statement that's on the report. To get report, it's in a element warning, we have plan convert and then looking for convert implicit. So show me, it's kind of filter. It's kind of internal filter. And plus, if I run without excluding sys schema, you will get, let me run, you will see that's many system. It's many system output. Oh, not here. It's a local machine, but in a real situation, you will see many system table calls. That's why I have additional filter, exclude sys schema. Okay, that's this way. You can make a screenshot, up to you, but this code will be uploaded to the session. So you can download it and run it. That's tested and runs practically on any server instances. I have it on a number of years. I developed a while ago. So now let's talk about extended event. What's next one? Extended event? Okay. If anyone have a quick question when I open up next session. Okay, I have extended event. I created extended event, and I would like to create report. That's That's the report, let me see, for database right here. It's on a server base. Server object, server management, extended event session. So I have query capture session. No, it's wrong file. Just a second, I put it extend. Okay. In extended event, to create extended event, it's not a big deal. You can go to session, right mouse click, new session wizard, and you can go over that. Then create report. What you need to know, extended event have two major blocks. It's a data and action. If you have report and you need to add any additional column to parse, practically it's element to parse. What you need to do, for example, what I have statement, I have a statement from data, but I would like to show from action SQL text, and SQL text is not here. So what I need to do? Just a copy one of the blocks. So what I mentioned before, you have action and you have data. I have sample for data and I have sample for action. These samples you can find anywhere. Any extended event parsing have both of those. So if you need action, and that's going to be my SQL text. What? SQL text. And what I need to do, it's action, name SQL text. Copy this name. Remember, XML is key sensitive. Even SQL Server is not key sensitive. Everything related to XML is key sensitive. For example, function value. Let me run it first. So I just added SQL text at the end, up front of you. Now, just FYI, if you have such as error, you should know shift. Let me put, for example, V capital. And I don't want to run this anymore. It takes too much. That's already underlined. You see it's saying, I can't recognize value. It just ran a few seconds before. I just put V capital, Control Z. I put it back. So that you know is when you have deal with XML parsing, XPath language, everything is case sensitive. Everything what inside XML. The biggest problem, someone tried to, when type, try to do capital, like a camelback case or all capitals. Never do that. My recommendation when you do parsing from XML, open XML, and any element or attribute name, just highlight Control-C, Control-V for your security. Because, let me show you, select, I want to copy. I put S capital. You see, it's showing null. When XML parsing showing null, the worst thing working with XML, it doesn't raise error if XML doesn't recognize element or attribute. It's just saying, okay, it's something different that I have. I don't have it, null. So you saw up front of you, I just changed one character, make it uppercase. So when you have extended event and you need to add anything additional what you have, you open XML, for example, and you need to add additional, any additional attribute name. It's two blocks, data and action. What you need to do, you don't need to be XML guru or something else. Just to find out one example for action and one example for data. And you see it's a name attribute. You need just to put, just to copy a whole line as example and change attribute name that what you would like to show up. And that will work. And my recommendation, instead of, you can type it, but instead of type, Control-C, Control-V. That's our friend. What we have with time? What's next? Okay. Now, next thing what I would like to cover, it's a deadlock. Since 2016, we have built-in system health extended event. And this extended event, it's a have for us reporting for deadlock. I just ran yesterday, I generated deadlock. I built up deadlock purposely. So it returns XML. To parsing XML, specifically this XML, it's possible, but I wouldn't do that. It's easier to go and find what you need to see. You need to find who is a victim, who is blocker. So right here, it says I try to update one table, and that's blocking by another table. And that's already built up. It's installs in a SQL server. So it's a default installation. You don't need to do anything extra. Only what needed. It's not parsing for XML. It's just a retrieving. So needs to grab from sys DM diagnostics DMV and says, okay, give me path, add system health, start, give me any report, XEL. And then it's a pre-populate. It's better to pre-populate in a temp table because it could be big output. Run in a CTE, run this part in a CTE could run very long time. It takes lots of memory. So it's better to preload in a temp table. And then when you have report, just analyze deadlock report to see. Very often it could be index issue. It could be, by the way, convert implicit as well. So where query run longer. When query run longer than expected. Could be number of different cases why deadlock happen. For this session, I would like just show up how to obtain and what we have internally in the SQL server and how easily without a third-party tool take report. For example, IDERA, they have deadlock report, and I wrote XML. They have a deadlock report in XML format, kind of confusing. It's internally not easy to read. I wrote my own parser over that, just to grab their XML and massaging, showing report that more easy to read, but it's still some not easy stuff. Profiler, which is not recommended to, it's number one, it's a deprecated, I believe, from 2012, I believe, right? Microsoft deprecated a profiler, and that's why they recommend extended event, but extended event not very well adapted in the DBAs by very simple reason. You need to parse yourself XML, and I'm not blaming anyone. I know maybe I got lucky, but my first touch with XML was on the next year when it was released by documentation. XML release on 1999. My first touch on XML, it was at that time one of the famous internet company called Vertical Net. Now it doesn't, and unfortunately doesn't exist anymore. And that was very advanced company, technical savvy. And that was my first touch with XML. And from this point on each position, I dealing with XML, maybe because I never afraid to have a deal with that. But it's not scary. It's friendly when you know how to say hello and follow the rule. Rule number one for XML, XML is key sensitive. XPath since 2005, where XPath language was built up, key sensitive as well. Even you have a standard SQL Server installation. That's what you need to know. Rule number one. So, where we are? Okay. So, a few more things about. That's the conversion table for converting data type. One more thing what I would like to show why I am looking it's not so well displaying here. Why I am looking inside execution plan. For example, I have missing index report. And just out of curiosity, let me see what indexes inside the XML. Very often, DMV, missing XML, returns, or on the execution plan, you have only one column, missing index. But very often, when you open XML, when you open execution plan in the XML format, you can see more than one index over there. That's why I would recommend you from this day, just out of curiosity, when you have execution plan, open up and see what's inside. One more helpful thing for me. Just pretend we have a query with a number of joins, 5, 10, 12, whatever. And not all developer, they write a select statement clearly, what I meant. You have one, you're working on a specific SQL that doesn't work well. It has some issue. And several columns, just a column name, and you have listed number of tables, more than one, more than two, 12, 20, and you don't know what this column belongs to specific table. If you open up, let me quickly go back to an execution plan, open anyone right here, for example. I believe it stays. No? You have a complete list. It's a database, schema, table, and column. So if you need to know where this column belongs to, generate execution plan. Maybe not it's one physical, another one. Help me, please. It's estimated execution. Even estimated execution plan will show you reference to each column. That saves you time. Sometimes I need to know where the column are from, where it's coming from. So now it's time for short break. Let's take a 10 minutes break, and then we will continue in 10 minutes. Welcome back to session, and now Said take over next part of this session.
Yep. So, all right, welcome back from the break, everybody. As I was having a conversation up here with some questions, I do want to point out that this session is aimed at bringing mid-level people up a step to give you some tools that you can find your performance problems. It is not intended as a full deep dive into every performance problem you're going to have, okay? For instance, when we were talking about indexing itself is a very complex art, okay? And there are plenty of deep dive sessions on indexing. You know, when to include filters, when to include multiple keys, when to turn around and use include clauses, etc. So we didn't have time to go into that detail because we would never get out of the first subject. Okay, so we're trying to give you just the basics. Now I am going to talk about something I think is as equally as important as for my first subject here, as indexing, maybe even a little bit more important, and that's statistics, okay? So SQL Server keeps statistics every time you use something in a where clause or as part of a join on or something like that. If you don't have a key on it, okay, it's going to create statistics. By the way, every index, when you create it, creates statistics. Okay, so what's the statistic? What are these statistics? Well, they are a method that SQL Server uses to figure out how to do your queries. Okay, so when you turn around and you give a SQL Server a query, it has to turn around and figure out how to create that execution plan. You know, we all look at those execution plans all the time. The way it figures, one of the key ways it figures it out is it looks at the statistics, and the statistics tell it how much data is out there on that particular column that you're looking at. When you say this column equals that column, or you say this column equals this value, okay? It looks at the statistics, and that's going to tell it approximately how many rows. It knows how many rows are going to come back based on the statistics that are out there on that column. Okay, and this is how it turns around and figures out how to do its memory grants and so on. So statistics can really cripple your system if your statistics are out of date or don't exist. So when you look at your database, you're going to see some options here. Okay, and we have an option up here for auto create statistics. Okay, I would highly suggest that be set to true. Yeah, we can make it a little bigger. How's that? Okay. All right. So you have auto create statistics. Okay, that should be by default turned on. I would not turn that off unless you have a good reason to turn it off. And then right below it, you have a little bit below it, you have auto update statistics. I would also suggest you turn that on. Now that one by default is off. Okay, so what SQL Server will do there is it will figure out if your stats are out of date. So what will make your stat be out of date? Well, as you load data into your database, you do inserts, updates, deletes. Okay, the statistics are no longer valid. Could be no longer valid depending on what you're adding. So if you add a bunch more data in on that has more values in that column, okay, then the statistics for that column are out of date. Yes.
How about the auto create incremental statistics? That by default is not turned on, right?
Yeah, well, I would turn it on. Okay. The reason I say that is because it is actually to your detriment to have out-of-date statistics. This can cause performance problems even greater than not having an index, believe it or not. Okay. The other thing I would suggest is that the next value that we have here is the auto statistics update asynchronously. Okay. Now the default on that is false. I would turn that on as well because if you have a large update come in, okay, and the next query is going to hit the statistics and it's going to say, oh, these stats are out of date, and it's going to freeze your stack and go update the statistics. Now, usually it doesn't take long for that to happen, but it is freezing your query until those are done. Now, what asynchronous will do is it'll say, oh, all right, I'm going to continue with the bad stat, okay, for this query, but I'm going to kick off a stat query in background, and it will be available for the next query. So, that's something you can do. Now, you can force your stats to update, okay? And it's something you probably should consider in your maintenance plans. Okay, you can turn, just like you turn around and rebuild indexes and reorganize indexes, you should turn around and probably update your statistics periodically. And for some systems, that may even make more sense than turning these things on. But if you want something that's going to give you the best overall flow, you probably want to go in and fine tune these on your database. Now, this is the database level, okay? And the other thing I wanted to point out is that we now have max drop available at the database level. Now, who knows what max stop is? Yes? Degrees of parallelism. So SQL Server will turn around, and if your query is large enough, it's going to return a lot of rows because it can figure this out through the stats. It will turn around and break your query into little pieces. Okay, and it will create parallel streams, and it'll send that to work. So it'll send, you know, if you got like 8 processors on your system, it'll, you know, put, you know, 8 streams out there, maybe even more, to turn around and satisfy your query. And then it will combine them and give you the result at the end. Okay, on very large queries, this is very advantageous. Okay, makes things run a lot faster. On very small queries, or queries that have sensitivity to order, okay, this can be detrimental, okay? So you can turn around and put in what we call a DOP override. You could turn around and put a DOP override in of say 1. 0 basically leaves it up to SQL Server to determine how many to do, okay? But if you put 1 in, that means your query will never get parallelized, okay? It will never get fractured into little tiny pieces, okay? And if it's a really fast little query, that may be what you want because it takes, there's an overhead associated with taking that query and splitting it apart and combining it together. For large queries, that overhead is minimal, okay? For small queries, that overhead is enormous, okay? And can cause overall performance problems. So we're going to be talking about max stop later a little more, but I just wanted to let you know that you can actually set that at the database level now. That wasn't available before. So here we're going to look at the personal address in AdventureWorks, and as an example. So here we see we have our indexes, and as you can see, every index has a key. Okay, now I'm going to run this here in a minute so you can see this happen. But I turned around and ran a query on something that wasn't indexed. Okay, and as soon as I did that, because the auto create indexes was turned on, it created a system index. Okay, or not a system index, a system statistic. Okay, and so that I just wanted to point out that when you see stats that look like this, okay, that have these strange numbers in here, that is a system statistic that's being generated. All right, so let's take a look at this a little bit deeper. I have
Deep dive session. We need to look deeper.
yeah. Well, I did prepare a little bit for this. Okay, so here we are. This is our what I was showing here is the personal address table, and here are the indexes that we were just showing on the slide there. Okay, and I'm going to turn around and look at yes. Why did that happen? Hang on a minute. I must have to exit out of here.
I can run my machine.
Yeah, hang on a minute. This is a problem with. We get it out. We got it out. Okay.
Switch to my machine.
I think it's fine. We're fine now. We're fine. That was me not exiting out of PowerPoint, and PowerPoint kept the slide up. Okay, so that was my fault. I'm sorry. At any rate, so we have, so here I'm turning around and just basically looking at this table, and I am using modified date, okay, greater than 2014-0101, because I know there's some stuff out there greater than that. I'm choosing modified date because modified date is not one of our indexes. Okay, so when I execute this, okay. Whoops. When I execute this, then I'm going to get my information back, and these are little tables, so you're not going to notice the overhead on this, but because eventually the whole database is very small. But what I wanted you to see here is that when I refresh my stats, it just created that stat. That stat wasn't there a minute ago. Now it's there. Okay. And if we want to go and look and see what's in that stat, well, this is dropping the stat, so let's not drop the stat just yet. Let's look at it. So we have this DBCC show stats. So this is going to turn around and show you everything that's in the stat. So you can kind of see here, this is where it's turning around and has basically what I call a histogram. If you've ever taken math class, you'll understand that. But deep math class. Anyway, but this is what it's turning around and doing. So this is the information that it's looking at. It's got the high hit key values here, and how many rows are in that set. So there's 82 rows here, okay, and what the variances are, and so on. So this is the information that SQL Server uses to figure out how much memory it's going to have to set aside, and how it's going to what type of matching algorithm it's going to do when you start and do joins and things. So this information is critical to SQL Server. So I just wanted to go over, kind of what's in there, but we don't have time to actually talk in depth about what this is, how these are used. But trust me, it's important. Okay, so now let's turn around and let's drop that system stat. So I'm going to drop the system stat. And now what I'm going to do is show you, well, that's not there anymore. What I'm going to do is show you that you can create your own stat, okay? So here we can turn around and say create stat. So if you have a field that you know is important, you can turn around and create stat. The with full system, the full scan is going to make that stat more precise. Okay, by default, SQL Server only will, I believe, scan 50%. So it'll take like samplings and create the stats from that.
The update stat?
Yeah.
5%.
5%, excuse me.
5% by default, take 5%.
Yeah.
Remember that.
Yeah, 5%, excuse me, not 50%, 5%. So the full scan takes the whole table. So you get a very, very, a very good stat, but it takes a lot longer to produce, especially on large tables. So this is something like if you were doing this on a large table, you want to do that like, off hours, when there's not much going on the system, because, it's going to beat your system up a little bit, creating that stat. So we can create this stat. Okay, now when we come and refresh our stats, hey, we've got a stat for that thing now. Okay, and we can turn around and we can show that stat. And, because this is not a large table, the stat isn't that different, okay? But again, this information is critical here for if we had taken and matched these two up to the one the system created and this one, because this one's a full stat, you would see slight differences in it, okay? So, but not huge differences. because this is a small table. All right. So I just wanted to show that off to show off the, how stats work. When you look at a stat in the GUI, you can get this information too. It's going to tell you what this stat is on, okay, and it's going to turn around and give you the details. So this is what I was showing you from the DBCC show stat, but it's available here to you too, so you can go look at it in here, okay, and you can apply filters to these things too. So if you need to, have a stat. Pay attention to this down here. It says these statistics were last updated, well, today, right now, because we just created it, okay, like a minute ago, okay? But if we turn around and we look at, see, one of these other stats, okay, you can see this stat hasn't been updated since 5/8/23, probably when AdventureWorks was created, okay? So this stat would have the possibility of being way out of date. So you would turn around and want to update this stat, okay, to make it more current, okay, if this was a busy table. So you can do that by just clicking here and clicking OK, or you can turn around and say script that, okay? I love the script that button, okay? And that basically turns around and does this, which is the, how you would code it if you were going to code it. Generally, you're updating the stat as opposed to dropping it, but you could drop it and create a new one. So that's just a choice to be made there. I've never found that, turning this on causes anything anyway. Might be a little better for a large table. I don't know. Anyway, so I just wanted to go over stats and make sure everybody understands how important they are and how they work, okay, in general. Again, this is another thing that could have its own deep dive session. All right, so let's go forward. Here's a few server options I would recommend. This is away from stats now. We're going to talk about some server options that you should be looking at when you're setting your SQL Server up and making sure you set. One of the biggest ones is max memory. Okay, so we have minimum memory and we have max memory. Be careful when you set these. Okay, when you set them, if you set them too low. Okay, either one of them, if you set them too low, SQL Server will crash because it can't allocate enough memory to run. Okay, so
Never go.
so be very, very careful, to make sure that you set this. This default number here is
It's a high integer value.
Yeah.
2,147,000,000. That's what I remember.
Yeah. Any rate, so but like I've said, you make sure when you're say like allocating 64 gig, because this is specified in K, or megabytes. This is specified in megabytes. We're not used to setting things in megabytes. Okay, so if you put 64 in, that's not enough for SQL Server to run in because that's 64 megabytes, okay? You need to make sure it's 64,000, okay? So, just be aware, when you set those, just, danger, Will Robinson, because that can cause issues. If you don't know exactly how much memory your system has, when you go to the general page, it'll actually tell you how much memory, or at least how much memory SQL sees, okay? And it also tells you the number of processors that it sees, okay, which is going to become relevant on the next tab.
One point. On the latest SQL Server installation, Microsoft added recommended memory settings.
Yes.
So make sure you select it.
Yes.
And then it's a provide best possibility for your server calculation and not occupied, because number what Microsoft put by default, it's a high integer number. What I remember, it's a 2,147,000,000, blah, 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 to the end.
Yeah.
So, but it tried to occupy everything. And that's, in the most time, it's a server issue. Best practice, it's 80-85% of the system memory. But latest installation for the SQL Server that have the added option, add optimized memory. So you don't need to make hand calculation on that. That's installed with proper settings.
Right.
Just to keep eye on installation.
And the reason you don't want to use all memory is because the operating system has to do things every once in a while, like allocate space for your ever-growing table, okay, or other things. Even your SQL Server, if you're running batch jobs on it, turns around and needs some head space. So if SQL Server is using every bit of memory, okay, what has to happen is SQL Server has to turn around and make room, okay? So, you know, it has to go through what's called garbage collection, and that's an intense process. So the best thing to do, yes? Yes, if you're going to have multiple instances, you need to divide the amount of memory that's physical on the machine, okay? So you want to turn around and say, hey, I want, you know, if you leave it on, it'll work, okay? But it just won't work well, and it can be a performance problem, okay? Because everything's going to be fighting back and forth for memory. This also includes turning on other services like integration services and analysis services. These things are going to fight for memory, okay? So you need to make sure that you put a value in here that makes sense, okay? And if you've got a very busy server with multiple instances on it or multiple services running, you need to maybe cut that memory down even more than 85%. Yes? Yes.
Somewhere between 75 and 80% of the memory utilization for SQL, or calculated properly ahead.
Yes.
85 will be definitely too high.
Yeah, it depends on what you're running on the server. Like you said, if you're running virus scanners that turn around and occupy a lot of memory, that can be an issue. Actually, by the way, just as a side note, normally I exclude SQL Server, the SQL Server itself, and the data types, the data files from scanning, because there's a lot of overhead involved in scanning those, over scanning those files. So that's just as a side note, as an operational thing. But getting back to the memory, yes, you're going to have to make sure that you put a number in here that makes sense. My company runs a product called HVR, which turns around and it runs on the SQL Server, and it consumes a lot of memory. Okay, so sometimes we have to cut it down to even maybe 50% of memory, because this HVR product needs all this additional memory to process. That's another reason I don't recommend you put other things on your SQL Server, because SQL servers are expensive. They're expensive resource. So having other things on that server is probably going to cost you money because of how expensive the licenses are. But anyway, moving forward, because we can keep moving. So in addition to these, there's another panel that is the advanced options, And when you come down on that, you're going to see two parameters here, max degree of parallelism, and your the cost threshold for parallelism, and again we have our max degree of parallelism, the max stop that we showed in the other slide. Okay, so by default, SQL Server sets this max degree of parallelism, the threshold cost, to 5%. That's going to cause a lot of little tiny queries to get parallel streams, which is counterproductive because of the overhead I was talking about before. Every time you go into a parallel query, to tear it apart costs a little bit of overhead, okay, for it to tear it apart into the streams, and then at the end it has to combine the stuff back together. That also is going to have a little bit of an overhead. And it's like kind of like a horse race going too. So every stream, all the streams got to come back together in order for it to proceed to the next step. Okay, so I think of it kind of like a diamond. They're all going out here, and then they've all got to come back and match up. Now, like I said again, on very large queries, that is, you can process billions of rows very quickly with that type of process. Okay, but if you've got something that goes against a small table that returns like 10 rows, okay, it's ridiculous to turn around and go through that overhead to tear it apart, put it into streams, and combine it back together. And it will slow your system down if you have too much of that going on. So one of the things I tell everybody to do is to set this to like 25 or 30 instead of 5%, so that only the large, expensive queries get parallelized. We don't want parallelized. Are actually torn apart into the streams because it's like I said, it's counterproductive for small queries. And then the max degree of parallelism. So by default, the 0 means that it's going to let SQL is going to determine how many streams it's going to use. So it could tear it into 50 or 100 parts. Okay. Typically, you only want to have it. My recommendation here is to set it to half of whatever the processors are. So if you got 8 processors, set it to 4. That allows 2 parallelized queries to run at the same time. Okay. I would not set it to the maximum number of CPUs because that can create bottlenecks, okay? So by rule of thumb, I usually use that. Now there's some debate as to whether you need a control CPU on some of the larger systems. So they say subtract 1 before you divide it in half so that you have 1 control CPU. I think half is good enough, but if you want to subtract 1, go for it. And then you would have your 8 processors, subtract 1, you'd say 7, and then you would divide by 2, which doesn't divide by 2. So you would set it to 3 instead of 4, okay, to allow for some control operations to occur. But these can help with performance quite a bit, making sure that your memory's set properly and making sure that these couple of options here are set properly. All right, so let's talk about Query Store in what they're calling the Intelligent Query Processing, IQP, okay? This is basically a roadmap that shows you what's been coming out, to features they've been putting into SQL Server to make it smarter in the query processing. This is where you give it a query and it figures out how to process it, okay? And it figures out how to process it, basically, every time we turn around and we upgrade SQL Server, we find out it runs a little faster, okay? And a lot of that has to do with them making this intelligent query processing piece smarter. Okay, so it's going to do smarter things with your queries to turn around and tune them. So what's here in the light blue is things that came out in 2017. Things that are in white are things that came out in 2019. And the stuff I'm really excited about is the stuff that came out in 2022. Okay, so SQL Server 2022 is adding these pieces here, these things in dark blue here. Okay, and a lot of these are going to give you give you what they call feedback. Again, these slides are going to be available to you, so you're welcome to take screenshots if you want, but they're going to be available. They're calling it feedback. I would call this the start of like AI inside the database engine. It's rudimentary AI. Okay, let's take a look at the cycle that we go through. So when they talk about feedback, okay, it's learn, adapt, verify. And then it learns and adapts and verifies. So it's the things that turn around and do feedback are going through this loop to figure out whether the query that it's just executed is any better than the query it executed before. And if not, it's going to tune it, okay, to work better in various aspects, which we're going to get to in a minute here. Okay, and so that's the adapt part. Okay, and then it's going to verify that the change that it made led to better performance. If it did, great. If it didn't, then it's going to learn again from that cycle, and it's going to keep reiterating till it gets a better, a better query for you, a better query plan for you. So the things that they're doing, and the reason, by the way, reason I had Query Store on these slides before we jump into this is that you need to turn Query Store on by default in 2022. Anytime you create a new database, Query Store is on by default. Now, what Query Store does is it's going to save information about how your queries are processing. Okay. So it's going to save the query plans. It's going to save various information about the query plans. Well, guess what? That's what's going to make the query plans run a lot better in SQL Server. That's what makes this, when we turned around and had this here, having the Query Store available means that it doesn't forget. Okay, like when you reboot the server, prior to 2022, okay, when you reboot the server, these learning things would be, you'd be given a lobotomy, and you would turn around and say, oh, you got to wait for the server to warm up before the queries run fast again. And this is one of the reasons why. Okay, is because you're getting rid of all that learning information. Well, now we're going to turn around and start saving some of that information in the Query Store. Okay, so here are the new features in 2022 that I'm really excited about. Okay, you got your coordinality estimations. Feedback. Like I said, every time you have feedback, that means it's going through that learning loop and figuring out what the better query plan is. And this is the big one for me. Okay, max degree of parallelism feedback. So this means that it's going to turn around and say, oh, having all the processors run on my query isn't efficient. Let's try half. Okay, if that worked, then let's try something less. It'll fine tune literally automatically, okay, what the proper max drop is for each individual query, which is really a good feature. okay? Because we have had to take a sledgehammer to the server and sit there and go, no, set the max drop to 1 on the whole server when only a handful of queries need it. Okay, and now we have the ability to turn around and say, well, we can set it at the database level. That's still a smaller sledgehammer, but still you're ruining all the other queries that run that could take advantage of degrees of parallelism that can't because of your settings. So by doing this, it's going to learn what the proper degree of parallelism is for the best query. So your queries will get better. And what's more important here is that this learning cycle again is going to be kept. The information for it is going to be kept in Query Store. So that means that when you reboot your server, it doesn't have to go through it again. It picks right back up and it says, hey, I know the best max drop for this query is 4, or I know the best max drop for this query is 8, or I know the best max drop for this query is 1, okay? And it doesn't lose that intelligence. So it's very important. Memory grants is another thing. This feedback loop's been in, I believe, since 2017, but now it's going to be stored in Query Store. So again, it's not going to forget it every time it reboots. So when your query plane is created, it turns around and figures out how much memory you're going to use. Okay, to generate that query based on estimations that it came up with through the stats, okay? If you go over the amount of memory that is allocated for that query because the stats are out of date or because, bad code, okay, which is the vein of our existence, whatever the reason is, it's going to consume more memory. You end up with what's called memory spills. Memory spills are something are very bad performance in SQL Server. It basically ends up and says, I don't have enough memory set aside for you. I don't have time to go allocate more memory for you because I'm running all these other queries, okay? So your stuff's going to be flushed to TempDB, okay? And you're going to run in TempDB, okay? TempDB is like a million times slower than main memory, okay? So, well, not a million times, but it's slower, okay, than working in main memory. So, you want to avoid that sort of thing. And now that we have memory grant feedback that's going to be kept in the Query Store, it will fine tune that. So they'll say, oh, I know that this is really going to take twice as much memory as I thought it was going to take based on the stats. So I will allocate the twice as much memory for you. So it's there for you. So you don't spill to TempDB. Okay, optimization plan forcing. Okay, this will turn around and basically it remembers the prior plan. Okay, or the prior couple plans in the Query Store, and it's part of what it does is it's going to say, oh, did I create a bad? Did I make a boo-boo? Is the query plane that I just created, that just executed, worse than the last one? If it's worse than the last one, forget about this one. We're going back to the one that worked. Okay. So a lot of times we have to turn around and have had to do this either through force plan and Query Store, which is something that's been there for a while, where you could turn around and say, oh, this is the plan that works. This is the plan that's 10 times faster than the other plan. I want that plan to run anytime it sees this SQL. Or we turn around and use what they call plan guides to do that same type of thing. Okay. This is going to turn around and kind of do that automatically because it's going to turn around and say, I'm not going to use the bad plan. When I see it, when I realize I've created a plan that's 10 times worse than the prior plan, I'm going back to the prior plan or going back to the prior second plan or whatever the most optimal plan that it has in its cache and query store. Parameter sensitivity plan optimization. This is another one that's really great, okay? Right now we have parameter sniffing, okay? So, what it's going to do is it's going to turn around and look at your parameters, use the stats to figure out what the optimum plan is for that. Now, the problem with that is that if your plan is cached, let's say the parameters you put in returned a very small return set or row set, okay, for the first time when it compiled it, okay. Well, now your parameters have changed and it creates a huge set. It's still using the plan from the first parameter sniff. Okay, so parameter sniffing has always had this bad caveat of there can only be one. Okay, this relieves that by turning around and saying we can create flavors of plans based on the parameters that we've seen come in. So we could turn around and have a cache plan that sits out there for the simple row set. Okay, oh, this is a simple row set one. We'll turn around and use the simple plan for that. The medium complex one for the medium plan, and the really large complex one for the large plan based on the parameters. So this is also another big optimization thing that you can just turn on by turning on turning these things on, upgrading to 2022 and turning these things on, making sure query store is turned on. And you get all these extra features. And the other one probably doesn't mean a lot to you, secondary replicant in availability groups. So, basically the lessons that it learns on the primary, okay, you can turn around and have those lessons carried over onto your secondary, your read replica. If you have a readable secondary set up in your always on group. You can basically share the smarts over and across. So that's the thing there. Going forward now, I'm switching gears here and going to talk about process information. So when you run SP Who2 or any other, you turn around and use any of the system monitors that show you the process information, they're going to show you SQL Server can only do three things, okay? It can either run your query, it can suspend your query, or it can make it runnable. Now, runnable basically means that it is no longer suspended, but it's waiting for like available CPUs or available, it's basically scheduled to run. You'll very seldom see this runnable up here, but you'll see these these things in your when you're looking at your processes, and it can only either be running, suspended, or runnable. Like I say, runnable, very unlikely you'll catch it in runnable, but occasionally you'll see it. Suspended is basically means that it's going to be into a wait state, okay? So that means your query is waiting on something, okay? So everything, all the modern tools that you see the vendors provide out here do what's called wait type analysis. Okay, so we want to know what our wait types are, what types of wait types we can have. Now, next slide is showing you the wait types. Okay, now this is just the top 10 wait types that occur on SQL Server. Okay, and along with what they mean. There are, I think, literally like over 100 different wait types. Okay, but most of them are very rare. Okay, number one is CX packet. A CS packet means that it's waiting on parallelism. Okay, so this is, suggests inefficiency in the query, i.e. bad code, okay? So if you're over parallelizing, when I talked about those small queries being broken into streams, you're going to see these CX packet weights pile up out there, okay? Because it's waiting to do the parameterization. The locks, these are when it's turning around and waiting on between resources. Not a lot you can do about that, but you can potentially look at this and find issues where you're doing your blocking or deadlocking. So if you see the locks, the XX means that there can be some letters there because there's a number of them. There's MS for shared lock. U, I believe there's an X for exclusive, so on. The different types of locks that occur. If you see the lock, if you see see your queries waiting in these things, you can turn around and try to trace down and find out what that query is, why it's waiting on things. And then we have page latch. Page latch means that it's going out to disk for something, generally. And again, there's different, the XX means there's different types of page latches, but page latch is when you're waiting on your disk drives to respond, okay? And then SQL CLR is, it turns around and that's when it's executing code. So just a side note, CLR, be very careful how you code CLR. Make sure your developers who are coding the CLR are versed in how to code CLR. It is not the same as just whipping up a .NET program and throwing it in SQL Server. If you throw, bad code in there, okay, it can do nasty things to your SQL Server. So be very careful with that. And, you could have CLR waits occur because of that. Thread protocol, okay? This is where it's waiting on worker threads. This can happen for a number of reasons. It also can happen, by the way, because of parallelism. So that's another one that you can see show up. This is the one I love, asynchronous network I/O. This is the lovely wait type where you get to blame the other group, okay? Because this is not SQL Server's fault, okay? It's waiting on the client or the network to do something, okay? So if we create, a billion rows and send it to a little laptop across the network, there's a good chance the little laptop won't be able to receive the billion rows lickety-split, okay? So that query is going to start chugging because it's waiting for that little laptop to catch up with the billion rows that just got thrown at it. SQL Server is more than capable of throwing the billion rows or trillion rows at it very quickly, but the network and or the client side is not. So when you see asynchronous network I/O, good news is you get to blame probably another group for that. The SOS scheduler yield, this is when it's turning around and trying to find CPUs to allocate for your thing. This is one of the reasons you don't want to over allocate on parallelism, because then you're going to turn around and see a lot of these things spread out, because if it's turning around and say taking your query and splitting it into 64 streams because you've used 0 for infinite number of streams and you only have 8 processors, well, some of those are going to have to go and wait to wait for processors to become available. So, that's another one you'll see, a lot with parallelism, but other things can create that too. It's waiting for CPU to become available, basically. And then write log is basically it's trying to write out transaction logs. This happens during checkpoint operations. And we have resource semaphore. This is memory pressure. You don't usually see this one. I'm not sure why it made the top 10, but I guess they're saying it does. But you know, if you see that, that means you've got some memory pressure going on. And then the backup buffer, which is when you're doing backups, basically it's locking up some system resource to do the backup. So your backups could be waiting on the backup buffer. So that is what I had prepared to talk about. I'm trying to give you something, and by the way, it's question time.
Not yet, just a second.
Wait.
Would you please switch? Would you
Yes.
please switch?
All right.
Actually, it's up to you, audience. We have 2 suggestions for you. I have number of, I would call this part, most common transact SQL mistakes based on my own experience and past about, let's say, 10 years or so. My major responsibility was and is a code review. So I provide lots of code review over the not only DBAs, .NET, and all over the code in a big company what I am working with right now. So I would like to go over some most common mistakes, kind of, not a mistakes, I would say inefficiency. Code works, but it could be better. And that could be better because not everyone up to date with functionality. And sometimes even functionality and advantages that released in 2005 not well utilized in a current code. Not everyone aware of that. Everyone is different. Someone do better, someone do. We're not criticize. We just go over. I would like go over the code and maybe I just put few comments what I would like to add to this session. Number 1. SQL Server practically doesn't have memory leak, but Said just mentioned about CLR. Other than CLR, memory leak could come from old-fashioned coding of XML processing function that available on a SQL 2000. It calls OpenXML. Why it's have an issue? Developers to process and use OpenXML is required. Just you must use it. SPXML prepared document that release available point for a document and send forward so XML can be processed. So developers must use this function to process XML on an old-fashioned way, but they often forgot to release it. And for OpenXML, SQL Server doesn't have garbage collection for like C# or another .NET languages. That means when prepare XML executed, its pointer and everything what related to this XML document lives in the memory and never released. It stays there. And in a situation, I got call once, SQL Server, end of the week, kind of crawling, it's a dying. When they reboot, it comes back to normal situation. I ran, it's a DMV to find, I wrote this process that sniffing specific keyword on each object, a store procedure, trigger, function, whatever it is. And when I searching for OpenXML, very often I see that it's a generating document, but it's never released. When it's added, a release document, better don't use OpenXML. It's an outdated technology. Use XPath. It's better. It's not OpenXML required create a document pointer for each individual XML. So you're dealing with cursor versus XPath, how I demonstrated before. You go through a whole column in a one shot. So that's the two options. If you just would like to preserve legacy code, just make sure release document exists. Store procedure, release document exists. Or your server will suffer memory issue. Kind of, it's a memory leak issue. It's going to be die over the period because it creates, creates pointer to the document and loading in the memory. Or rewrite it using XPath. That's the first thing. Another thing what I would like to mention about deadlock. Microsoft already released on Azure and going to release on-prem a new feature it calls optimized locking. That practically they try to maybe not 100% solve, but at least some release over deadlocking, kind of make it more logical available for processing and make sure request complete process, even it's in a deadlock issue. So now, what do you think? You would like to go to questions section, or I can do more demo about coding? Coding. Okay. We're gonna vote.
Okay, bad code it is then.
Okay. Now let's go to quote unquote bad code.
Can you actually make this font slightly bigger?
Sure, absolutely.
Projector is out of focus.
That's good enough. Big enough. So I just would like to demo indexing. We spoke about convert implicit, which is creates behind the scene, but such as where clause, I see a lot. And this where clause, let me run the query, and you see it's a clustered index scan. Can you see it? It's a clustered index scan. Now let me uncomment this one and comment this thing. Now index seek. Solution, it's very easy. That's what I mentioned before. This part right here, I would call it's an explicit. It's an explicit processing over the column. So if on a where clause over the column process with a function, index not visible by cardinality estimator, and they just ignore it simply. So if you need to provide date slice, like give me specific year and specific months, instead of writing year function and then months function, just to do between and actual date. That's simple as that, and I saw such a code a lot.
Right.
And it's much easier.
Excuse me. That's true for any function, just about any function you put in the where clause. Okay. Don't put where functions in the don't put functions in the where clause unless you absolutely have to, because you're probably going to trigger some sort of scan, whether it's an index scan or a table scan.
That's the practical
and it's going to be bad performance.
And UDF, user-defined function, even worse.
Yes.
So Next one, yeah, it's a, I just go quickly. Next example. This example produce, I need to change database. And that's create convert implicit. But previously we spoke about nvarchar and varchar, so difference between Unicode string and ANSI standard string. That's another example when column is string, but value passed as an integer. If you remember data type precedence, integer one of the top. So make sure it's a correct data type sent. That's addition to my beginning session. Just not only nvarchar and varchar have a problem. Anything in a data type precedence, if you try to apply something that over on a sequence over the original one, it's going to be convert implicit. So it's easy to fix. Practically need to just to say, developer, please make sure it's a varchar or nvarchar, depends of the column. No, big integer, if I need go to big integer before integer. If you have big integer and try to add integer, it's nothing happen. Because integer under big integer, it's not a conflict type. You with me? It's a sequence. We're talking about if it's integer and varchar, big integer above the integer. So it's not generate convert implicit. Next one, what I would like to say. Yes.
Well, the one thing you got to understand, anytime you do what he's talking about, when you have a conversion, that's a function. I said, don't you put functions in where clauses. It's basically SQL Server saying, oh, these don't match, so I'm going to have to create a conversion to convert it. And that's a function, okay? So every time you do a function, you're probably going to get a seek or a scan of some sort.
Yeah, I can go back to that code and show you inside that's initially what I show inside the execution plan. It's a function convert implicit that says, okay, I have a column, and this column needs to be converted to a different data type. And column inside the execution plan, it becomes to processed the same as I show you year and month. Yes, what's your question?
I've always heard that it's not good to use functions on the column, but like on a value, it's okay.
Yeah, it's a value okay. We're talking about column because do you have index on a value?
No.
What? Yeah. We're talking about index.
Well,
yeah. Function over the value, not a problem because we're talking about column. Column have an index. Value doesn't have an index. If I could assume why Microsoft provide convert implicit over the column rather than over the value, because column it's a built-in, and they can't touch user input. So by maybe, it's my assumption, by the rule of processing data, you can't touch user data. If Microsoft put convert, if Microsoft see, execution plan see, okay, I have varchar, but it's coming nvarchar. Why execution plan doesn't put convert over the value? Because value cannot be touched. It's a user input. Who knows? So to process, it's a victim is a column. That's why it's happened. So over the value, absolutely. Value doesn't have an index.
Right. Well, yeah.
It's a value.
Another thing is that anytime you use a function in a where clause, okay, whether it's implied or not, okay, that is going to have to turn around and retrieve the row and put that value through the function to figure out whether or not that your equals or greater than or whatever it is you've said matches or doesn't match. Okay, it doesn't have a way of like applying the function to the entire data set. Okay, and getting those results. You know, you would have to create a view for that. If you wanted to create a view, you could create a materialized view and then go against that value, okay? And then you would solve it that way. But when you have a function inside the where clause, SQL Server has to retrieve every piece of information and apply that function to it, okay? And that's why it does that. Yes, way in the back. Yes, anytime you use any type of equals anywhere.
It could be on a join as well.
If you're doing
everything
it,
it
it's a
doesn't
good point.
match. Yeah, sorry, we step
Yes.
up on each other.
Yes,
That's everything what make it a comparison.
Yes.
That could trigger that. So let me continue. Maybe you know, but just a FYI, lead and lag functions. I saw many processes that generate cursor. For example, I need to stay on a one row and read next row. And what developer do, because they need kind of compare. I am in a row 1, needs to read row 2. Row 2 needs to, so kind of continuous read next row or jump in a row. SQL Server 2012, I believe, they released windowing function, analytical windowing function. One of those, it's a lead and lag. The difference is lead, reading next, depends on what you put in the parameters. For here, I put 1. That means I'm reading next. Stay on a row 1, but reading row 2. I can put 3 or 4, that means I jump. But I saw many cursors because developers not aware this functionality exists. Maybe you know, maybe just wasting time, but just FYI. Output clause, very important thing. And before output clause, one of the issues that when I see and correct it, that's improved performance. It's a subquerying in a where clause. But in this case, I need a little bit correct myself. It cannot be 100%, needs to be tested. Sometimes it works and SQL Server process 4 joins very well. After 4 joins, each next one, if you have big number of joins, that could be performance issue as well. Sometimes in a situation, I was in a position when instead of joining specific table, I wrote, for example, inline subquery. And that's help. So you know what the trick about performance issue? It cannot be white and black. It's something, sometimes it's a gray, green, or whatever it is. Everything needs to be tested well. If you see some query doesn't perform well, and you have a solution, test it. Test different solution. But sometimes that's it's possibility. For example, in my profile, I have a deal with table, which is size of the one table, near terabyte. It's 800 something, huge table, billions and billions rows. And what you expect? if using clustered indexes or just straight indexes, right, its returns kind of depends number of rows returns, what needs to be returned. But something more, it could be run slow just naturally, and you can't do anything about it. It's lots of data, and report needs to be delivered. It could run slow. It's a recommendation, but it needs to be tested. I can't say 100%, but when I see subquerying in a where clause, I try to create, so instead of that, I would use that. Add subquery table that in the subquery, add to join. But in this case, you see, I already have 1, 2, 3, 4, 5. It's going to be 6 table. So in this case, it needs to be tested very well. And that could be case. So it's not good way to substitute subquery with join. But I would say 80% or more subquerying in a where clause, it's a performance issue. It needs to be, and it's easy to fix. Just you need to bring this subquerying table in a join and make criteria in a where clause. Simple as that. So output clause, that's my favorite. In a traditional way, we have sort normal form. That means we have table product, we have table, I have order details and orders. So product, order details, and orders. So in one product could be in many orders, and many orders could have one product. To solve it, we have a mid table that calls order details that allows us solve third it's a sort normalization form. I'm tired, sorry. So traditional way, we have number of rows, 10, 50, 100, whatever it is. And when we insert in an order, to put record on the order details, we need to obtain order ID, which is going to be generated. That's why just in a normal mentality, I inserted order, I got order details, product ID I already have. So that's my, this order have such as product, and this product in a such as order. Logically correct, right? So that's, in the most cases, that creates cursor, what you see right here. It's a create cursor, and then grab each one and take a newly generated ID, and that's how order details generates. That it's a regular way. Now for output clause. Let me make a little bit smaller so you can see. In the output clause, it works this way. I don't need to create a cursor, operate a set batch. First, all orders inserted in a one batch, in a one shot. And then output clause, put all newly generated ID in a table that my middle table. In most cases, it could be table variable or temp table, any storage, wherever you're comfortable with. And then when I have all IDs in one shot, then using joins, it applies to order details as a batch. So first batch generates order ID, and another batch grab this order ID along with product ID, add to the table. It's a significant difference between cursor-based and set-based. It's a set-based process. Another way how we could use output clause. For example, you have unique identifier. You can't predict what like a new ID, the same unique identifier, how you could know what the ID going to be next. Practically impossible, because unique identifier, it generates set of hexadecimal values, not just a numeric what we used in a regular int. So in the output clause, I could, that's the what inserted in a table, and that's IDs that capture it. I just use insert, and then what inserted output in a temporary storage. Before temporal tables, output clause, it's very good functionality for archiving. You can do, if something, I saw number of processes, what they doing, they first deleting, reading values, sending to archive table, and after that second set, they deleting values. Instead of 2 shots, you can do 1. So delete, as you see right here, and output clause streaming all to archive table. And at 2016, we have new technology, relatively new. It calls temporal table. I have article you can find on a simple talk. I have detailed article how to generate new or convert existing table to temporal tables. And in several clients, I implemented this feature, works very well, specifically for update. It works with temporal tables very good. So what else? String egg. This function available on a 2017. Before that, I used kind of XML processing. What it does? For I have table, just an example, but I would like to convert second column, which is name, into delimited string in a one. So I have listed kind of suppressed data. I have one value, and then streaming all columns, just a comma delimited. I saw lots of cursors to do that. Okay, you grabbing value, and then another cursor just to add string, and then put on a output storage, temp table, or just to gather a result. So that's the 2 alternative. One alternative using, it's a combination stuff with 4 XML paths. So now I have a table, and the columns, list of column, it's a generate delimited string. Come on. Okay, right here. Or in a 2017, it's available string egg that does the same process. But that allows you to drop cursor. Okay, so it's if it's 2016 and lower, it's a stuff with open XML and string egg if we up to date. So I believe now we can go to questions. Yeah, we have. Actually, it's 10 minutes, but it could be more. Yes?
Do you have a demo for over the one memory over the memory grants?
Memory grants.
Or, the one where the very platter over allocated memory.
I have demo to showing where table variable using tempdb. It's a myth that in-memory table doesn't use storages. It's not true. It creates point for potential streaming data if result set bigger than memory could allocate. I have, yes, sure, just for you. So I have table variable, inserted value John, and then it's what the file start, and then open trace on dbcc page. Give me what pages now in attemptdb using those output for those values, and you can see the value right here, value John Smith. Right here, name John Smith. In attemptdb. So it's a proof that in-memory table using some pointer on attemptdb, but it's using in case your result set is too big to process by SQL Server. And that's why another way to optimize query, if you see in the store procedures, in a script, developers create table variable, but store procedure operates slow, try to replace table variable with temp table. It's probably result set is too big to process by in-memory SQL Server memory. That's why SQL, when it's realized, okay, I have result set, let's say 100,000 rows. I can't hold it. I can't hold a whole result in a memory. I need to additional storage. Where it's tempdb. That's my, tempdb it's working horse. That's group by, order by, that's all coming in attemptdb. So yes, you next. Yes, before 2019. On the 2019, SQL solved this issue. On the 2019 and up, SQL solved this issue, but this installation, what I'm running, it's a 2022. It's still showing tempdb using pointer. It doesn't mean it's explicitly using and put result over there, but using pointer for potential if something, if result set exceed memory allowance.
Yeah, remember what I said?
You're next, I remember.
You have, when SQL Server goes to execute your query, regardless of what it is, it's going to set aside the memory for you, okay? If that memory isn't adequate to what happens in the process, you end up with what we call a memory spill. And when you do a memory spill, you write out to tempdb. Now, what this is doing is it's turning around and basically prepping tempdb for a memory spill in case it needs it, okay? Which is a lot more efficient than actually going, oopsie, I need to do a memory spill, because that process is more intense.
You are next, I saw.
Regarding memory, I'm just curious, do you guys recommend turn the log page in memory on or not?
I normally do not turn that on. It's one of those things that's going to be when it depends. Yeah, I got this. It's one of these things that it depends.
Yep,
okay, the by turning lock memory on, what you're doing is telling SQL Server to reserve its page of memory. Now, SQL Server by default does not turn that on, and it doesn't turn it on for to optimize things when things happen on the server that needs extra memory. So SQL Server will turn around and say, oh, I need to pull this block of data into memory, and it'll put it there. And then if Windows comes along and says, oh dear, I need memory, and it consumes that block of memory because SQL Server hasn't locked it, then when SQL Server comes back, it says, oh dear, somebody used my memory, let me pull it back in again. Okay, so that requires some overhead to happen there. If you've done your memory allocations properly and so on, you can turn on locked memory, and now when Windows wants to go get that memory, it has to go do garbage collection and figure out some other place to put that memory, because that is now SQL Server's memory. And the only way it has to get rid of it is it has to ask SQL Server, would you please release that memory so I can use it? Okay, and there is, by the way, a protocol for that. Okay, which is also an intense overhead to have happen. You really don't want to be waiting for memory collections or allocations to occur, because those are going to require overhead.
Regarding CTE, is it operating the same way as the table variable?
No, CTE, it uses some memory. And by the way, thank you for this question. I just, it's one demo what I would like to show. CTE, it's a more organizing process over the SQL. It's an alternative to derived table what available on a 2000 or so. About CTE, be careful with multiple level of CTE. If on my own experience, but it's, it depends what system, many if, I can't tell you specific number, but what I saw, if you have deep level more than 4, CTE becomes a big issue. And when I see multiple level CTE, sometimes I try to split it, at least take one level off and put on a temp table or in memory table, depends of what table and what result could be. And then add to CTE as a regular join. And that's everything needs to be, this case, you can't find straightforward answer. That's case when I can tell that could be solution that you need to test. But be careful with multiple level CTE, CTE with CTE with CTE. For more than 4, forget it. Better to use couple temp table or table variable than join. Yeah, you're next, I saw.
So you're talking about open XML file, we need a garbage collection. How about if we open JSON file? The file is huge, and you say we need a
Open JSON file?
Yeah.
Yeah, it's this session not about JSON, but I have lots of processes in my current position with JSON, and files pretty much big in the megs. It's like a normal table. It takes time to be bigger JSON. Like XML and JSON, you can't compare. They could have multiple level, or one simple JSON could work in a second. Another with very deep and detailed array, when required more parsing, it works much slower. But open JSON works very well over the JSON file.
Yeah, the record is large, the file is large. Mm-hmm.
It doesn't matter. So that's the book. It's available on Amazon. Yeah, I have few. If someone interested, you can see me after session. You can get it with my signature. I have 2 of those. I brought on just in case.
I need one.
Yeah, A-Press, they should have it, but they reprinting. I just spoke in the morning. I look where my book is. Sorry, we're reprinting. Yes.
And is there a reason why we would create a statistics instead of an index, one or the other? Is there like, hey, it's better to create statistics here, but not an index?
Well, you know, I hate to keep coming back to this, but it depends. This is an architectural problem with how you use your table, okay, as to whether or not it's going to be more effective to have a stat or a full-blown index. I've once heard that one of our senior DBA people say that, you know, rebuilding an index is a very expensive way of updating stats. Which is probably true. The stats are vitally important to SQL Server as to how it creates that query. If you're utilizing it as a key, okay, when you're turning around and retrieving data, okay, yes, then you need to make it an index, okay? If you're using it as associated filtering criteria, that's where it turns around and gets iffy, okay, as to whether or not you should have it as an index or an include, or if you want to turn around and have a separate stat item for it. Now, keep in mind, if you got auto create stats on, if you use it in any sort of compare, whether it's in a join compare or a where clause or wherever, if you use it in a compare, SQL Server is going to create a stat for it. And you'll end up with a whole bunch of those WS things on your tables.
Okay, your question.
I think I heard you say that Deadlock is a new tool coming out to help with.
It's not a tool, it's a new feature in a SQL Server. It's available on Azure, already available, and going to be available on a new release. The same as a JSON data type. I know for sure because I work with Microsoft on a JSON data type. Optimized locking. Yeah, optimized locking, it's available on Azure. If you have installation on Azure, they turn on. Yes, sir.
I want to, if you see a lot of CX packet weight, is that necessarily a bad thing, or is it just because it's a necessary way for parallel query to run?
Sniff packet weights.
The CX packet weight that you mentioned?
Oh, the CX packet weight.
Yep.
Yeah.
You see a lot, right?
If you see a lot of those happening and you've got poor performance, that indicates you probably have a lot of over-parallelism happening. You know, and the fast way to, when you set max stop at the server level, okay, that's like a sledgehammer, and you can turn around and set it to 1, and you'll see those things fall, not within a minute. It will maybe take a minute or two for them to disappear, but they will disappear very quickly because the very next query won't be broken into a whole bunch of fragments. Like I said, you've got that overhead of tearing the streams apart and putting them back together. For big queries, that makes a lot of sense because compared to the overall execution, the overhead is small, okay? On little tiny queries, the overhead is huge and really causes a lot of performance problems.
How do you determine at what point it's too much overhead versus not enough parallel?
Yeah, well, see, that's why I'm excited about that new feedback feature in 2022, where it's going to turn around and check the max stop and turn around and try to fine tune it for you, okay? It's going to turn around and say, oh, this didn't execute well with that max stop. I'm going to change it to something else. And it'll keep fine tuning it until it finds the perfect value. If you have 2019, you got to use the sledgehammer, okay, approach. You can either turn around and put it at the server level, you can turn around and now put it at a database level, that's in 2019, I believe, or you can turn around and put a query hint in for the max stop. But the real big solution is to go to 2022 and let it learn.
Okay. So you can, if any questions, please contact me. That's the Said's and my personal information. If you need sample code or you have a questions, please contact and mention you were on a my session on a pass.
Right. And please don't forget to fill out your evals. Those count for us, so.
Thank you.
Use the memory or the
Will be uploaded.
you mean you said the CT used the memory or the template?
Okay, that's an Alex question, but it depends on. It's another one of those ones that depends, on how complex the CTE is.